Hello everybody and welcome to our note on 16D.2. We're just continuing talking about how we go from the graph of f of x to the graph of the derivative or the second derivative. Now in this example from your textbook we see a cubic function, and if we wanted to draw the first derivative, the first thing we need to do is find the points where the tangent, the slope of the tangent is equal to 0. So in this case that is right here and right here. So somewhere between, looks like about 1 and 3. So when the slope of the tangent is 0, we have a 0 on our derivative, and same thing here because the derivative represents the slopes of the tangents. So we have 2 zeros in my function. And I noticed that before this 0, my function is starting with steep positive slopes going to flatter positive slopes. So that means I'm going from high positive values to lower positive values. Beyond this point right here, I've got tangents that are increasing, so they're positive slopes going from flatter to steeper. So again, I'm going from lower positive values to higher positive values. And in between, I've got negative slopes, so I know that all of my graph will be below the x-axis, and I'm going from flat to steep to flat. So I'm going from low negative to more negative to less negative. Okay, and at this point here, I can see I have a point of inflection. So I'm changing in concavity there. Wherever I have a point of inflection, that means I have a 0 for my second derivative, okay, which means it's going to be a vertex or a stationary point on the graph of my derivative. Okay, so remember that my zeros in the graph of my derivative are stationary points on the original function, and an inflection point on the original function becomes a stationary point on the derivative, and that stationary point on the derivative becomes, becomes the inflection point. Sorry about that. Let's fix that. Okay, so wherever we have when I'm graphing the derivative of my derivative, remember I'm just going to treat this graph just like I did over there. Wherever I have the slope of the tangent equal to 0, that means I have a 0 on my second derivative function. Prior to that, my graph was decreasing, so I have negative tangent slopes going from steep to flat. So from high negative values to lower negative values, or I should say, I guess, more negative to less negative. And then on this side, I have values that are increasing. The slopes of my tangents are increasing. I'm going from flatter to steeper, so I'm going from less positive to more positive. So less positive to more positive. Okay. And if you think about the derivative, this is a cubic function. Its derivative by the power rule should be a quadratic function, and the derivative of a quadratic function should be a linear function. So that checks out. Okay, we have one more IB past paper question, and we'll look at that in our next video.